Alrighty, here we're going to finish up checkpoint 1.3, and let's do some rationalizing the denominator. This is about as simple as the rationalizing the denominator gets right here. Get rid of that root 7 in the denominator. We multiply the numerators together here. Multiply the denominators, that's how we multiply fractions. And we're left with root 7 over 7. That's your final answer there. Can't do anything more with that. Alright, next question. We're going to simplify square root of 120. So we want to milk all the perfect square radical juice milk out of there. And so we're going to look for the biggest perfect square, which I think would be root 4 times root 30. Root 4 is a 2, so that would be a 2 square root 30. Can you think of any factors of 30 that are perfect squares? I can't. Alright, 6 and 5, 10 and 3, 15 and 2, none are perfect squares, so we're kind of stuck there. Next one here, I'm going to use a little strategy on this one. I'm going to do, let's see, square root of, I'm going to try to cancel instead of rationalize. So I'm going to go with square root of 6 times the square root of 4, and that's going to be the same as over the square root of 9 over the square root of 6, I believe. And so, oh, look at what happens here. This is kind of neat. Root 6 factor, root 6 factor, those are gone. And root 9, that's just 3 over root 4 is 2. There we go. That worked out nice and happy. Next problem, let's kind of do the same strategy. Let's, instead of making a big number, let's look for pairs. So let's go root 5 times root 4 times root 5 times root 3. And whoa, what do you know? We got pairs of root 5s right there. Root 5 times root 5, that just turns into a 5. And then a 4, root 4, that turns into a 2. And a root 3 we can't do anything with. And so then we multiply those together. Don't add them, multiply them. And you get 10 root 3. Final answer. That's pretty sweet. Okay, then we cruise down to the bottom half of this checkpoint. Let's take a look at 4 root 3 squared. What does that mean? Well, that means multiply by itself. So 4 root 3 times 4 root 3, that's going to be 16 times 3, which is 48. So there we go. We got 48 right there. That's just a regular old 48. That's one way to say it. Number 6, we have to add some radicals, and we can't do that until these things match. The radical parts match, so let's see if this is a happy little problem. Little Bob Ross action there. So let's see, we get root 20, that's the same as root 5, root 4, and root 80, that's the same as root 16, root 5. Okay, well there we go. Don't forget the 2 there, and don't forget the 4 there. Let's clean these up a bit. Remember, we're adding them. So clean that up a bit. We got 2 times the square root of 4. That's going to be 2 times 2, so that's 4 root 5. Plus over here we got 4 times root 16 is 4, so those two multiplied together is going to be 4 times 4 is 16 root 5. Well, if you have 4 root 5s plus 16 root 5s, then you have a total of 20 root 5s. Ta-da! 20 root 5. Best we can do. 5 has no perfect square factors. Number 7 is everyone's favorite problem. This is rationalizing the denominator, and we have kind of a binomial going up top, so we're going to multiply that by root 5 over root 5. Okay, and then we've got to distribute this root 5 to both of those terms. So after we do that, we're going to be left with, let's see, give them more space here, we're going to be left with 5 root 15 plus 10 times root 5 times root 5 is 10 times 5, that's going to be 50 all over 5. Then of course I want to try to factor out what I can in that numerator there, so I'm going to take, which looks like I can take a 5 out. So I'm going to take a 5 out of both those terms, and so what I'm going to have then, if I slide over here a little bit, I'll go in red, I'm going to have 5 times the square root of 15 plus 10 all over 5, which means that I can reduce those 5s now because they're factors. My final answer, square root of 15 plus 10. Super duper. Okay, there you go, under 5 minutes for checkpoint 1.3.